Greetings everyone. Welcome to another lecture of circuits and system. In today's lecture, we are going to go with the systems and its classification. In this, we'll have introduction of systems, classification of system, and we'll study about a specific system called LTI. So, always remember, education is the most powerful weapon which you can use to change the world, as said by our President Nelson Mandela. So, gain this power and try to change the world for the good. So let's start. Now, what is a system? A system is a mathematical model of a physical process. Let us say this y is nothing but it is going to give you x square. Now, what does this system say? The system says whatever the input is coming, it will multiply it with itself and it will give us x square. So what is this? A system is something which relates input excitation to output. Okay. So similarly, we can have a multiple input and a multiple output system. So basically system is a mathematical model of a physical phenomena. Okay. Now, similarly, as we have two types of signal, we have a continuous time system, we have a discrete time system. Continuous time system, input is continuous, output is continuous. In discrete time system, input is discrete and output is discrete. So according to the input, we decide whether the system is continuous time or a discrete time system. So basic classification of system. So we have six such classification. First is linear, non-linear, time variant and time invariant, causal, non-causal, static, dynamic, stable, unstable, invertible and non-invertible. Now what is this linear system? What does this linear system says? It says if a system satisfies superposition plus homogeneity, then a system is a linear system. So a system which satisfies superposition and homogeneity is a linear system. Now what is time invariant? Time invariant system says if a system has an input xt gives a response yt. Now if I shift this response by let us say t naught, the similar shift will occur at the output. Okay, so if this is true, shifting of time in the case of input will not affect the output, then my system is time invariant. And if this is not happening, then my system is time variant. Then we have a causal and non-causal. What is causal? Causal system output will depend on past input, past output, and present input, but there'll be no future input in this case. So there'll be no future. So these systems are non-anticipatory. These systems are not anticipating what future is, what next input is going to be. For example, if you'll say, sir, no system can do that. No, we already practice those things. For example, prediction of rain. We predict that how much rain is going to be, and according to that we advise the farmers to take proper precaution for the crops. So what we are predicting, we are predicting the input in today's time and what is going to come in future. So non-causal system may exist, but these are just the prediction model. Now what is static? Now static system are memoryless. Memoryless. Now what is memoryless system? No past or future input or output is involved in present output. So my present output is not going to depend on any past input or past output or any future input or any future output. So what I can say, my static, let us say if I'm trying to calculate for a given xt, I have a system, I'm trying to calculate yt. So y0 at 0th interval will depend only on x0, what is present time input. So I can say that my static system, there's a saying, there's a linking between these two. What it is? So the link is all static systems are causal, but vice versa is not true. All static systems are causal, but its inverse is not true. Causal system may be static, may not be static, but if it has a system is static, it has to be causal. Stable and unstable. What does this system say? This system says for any bounded input, my output will be bounded. Let us say if I have an input xt, its magnitude is less than equal to some value m. It's not infinite, it's some value m. Then if my yt has a magnitude which is less than equal to n, any value other than minus infinity to plus and minus infinity and plus infinity or 0, then my system will be a stable system. For every bounded input, we call it as BO. For every bounded input, my output will also be bounded. Now, what are invertible systems? Invertible systems are systems which gives a unique output for an input. For example, let's just take two examples. You'll get this thing. Let us say I have a system which multiplies my input with R and gives me an output. So whatever my input is, xt, my output will be y is equals to R times xt. Okay. So if I place another system, if this system is multiplying with R, if I place another system that gives me 1 by R, so if I give xt over here, I get yt, again I'll get my xt back because once it will be multiplying with R, other time it will be dividing by R. But if I have a system which does x square, let us say x is the input, t or n, doesn't matter, it gives me y. Even though I place a signal, a circuit which does under root of x, this x cap may and may not be equal. So these signals are non-invertible. For example, if I take x as 2 and if I take x as minus 2, y in both the case will be 4. X in both the case will be 2. So at times it is equal to 2, but it is not equal to minus 2. So this system is non-invertible. So with these are the classifications of the system. We need to identify whether a specific system is a linear or non-linear, time variant invariant, causal non-causal, static dynamic, and stable unstable. And at times they ask you invertible and non-invertible too. So let's take down the first question. The first question says xt is an input, yt is an output, which is nothing but multiplication of cos omega ct with xt. And he wants us to find out whether the system is memoryless, causal, linear, time invariant, or stable. So let's start with linearity first. So linearity, if you want to prove, just do one thing. Let's take this system as S and I have given an input x1t. So what would be my y1t? My y1t will be, let's put it as ax1t. put it homogeneity as well. A x1t cos omega ct is my output. Let's give another input to the signal, to the same system. Let's say b x2t. So what would be my yt? My y2t will be b times x2t cos omega ct. Okay. So let's give another input, that is x3t, which is nothing but a times x1t plus b times x2t. Now what will this system give? The system will give me y3t, which is nothing but x3t multiplied by cos omega ct. This will give me a x1t cos omega ct plus b x2t cos omega ct. Now this y3t, if you see it carefully, is nothing but sum of y1t and y2t. So if I'm getting y3t is equals to y1t plus y2t, then my system is linear. So this system is linear system. Let's go and check time variance and invariance. So what is the response of my system? The response of my system is y of t is equals to xt cos omega ct. So first step, replace t by t minus t naught. So replace all the t by t minus t naught. Y t minus t naught is equals to x t minus t naught cos omega c t minus t naught. Now, before giving this, see what I've done. I've replaced all the t by t minus t naught in the output equation. Now, let us feed this input to the circuit. X of t minus t naught. I fed to the same system. What would be my output? My yt will be x of t minus t naught cos omega ct. See, my dear friends, here I have given x of t minus t naught. I haven't shifted anything with this cos. So what would be my output? My output would be x of t minus t naught cos omega ct. Now, if you see, my yt is not equal to y of t minus t naught. Hence, my system is a time varying system. Time varying system. देखो हो क्या रहा है यहां पर, जितना शिफ्ट मेरे टोटल में था, अगर मैंने सिर्फ इनपुट को शिफ्ट करके भेजा तो मेरा सिग्नल दोनों केसेस में अलग आया। तो इससे क्या हो रहा है कि मैं ये मान के चल रहा हूं कि अगर मेरा इनपुट शिफ्ट हो रहा है तो मेरा आउटपुट उस हिसाब से मॉडिफाई नहीं हो रहा। दैट इज कि सिस्टम टाइम के अकॉर्डिंग स्टेबल नहीं रह रहा है। Stable in the sense it's not giving us the same output. Now let us check causal and non-causal. Okay. Now my yt is nothing but xt cos omega ct. Now the easiest way is put t is equals to 0. So it would be y0. My present output will depend on x0 and cos 0. There is no future value. Put t is equals to 1. Y1 will be dependent on x1 and cos omega c. So there is again no future value. Hence, the system is causal. Okay, moving ahead. Now, if you see, same way, if y0 is dependent only on x0, y1 is dependent only on x1, there is no past value as well. Hence, the system is static as well. Okay, now stable and unstable. Now let us see. See, I have an input xt. I have an input xt. Let us see. Let's take magnitude of xt is less than some number mx. Okay, where mx is a finite number, whatever it is. Now let's just check whether the magnitude of yt is finite or not. Now magnitude of yt is dependent on magnitude of xt, which we have already fixed, and cos omega ct. Now magnitude of cos omega ct will always be less than or equal to 1. See, cos omega ct maximum value is going to be from 1 to -1. So it is going to be less than or equal to 1. And when we're talking about magnitude, it will always be in a positive direction. So if xt is a finite number, cos omega t is a finite number, multiplication of two finite number is going to give me a finite magnitude, let us say some magnitude n. So if y is having a finite magnitude and I've considered my input to be a bounded input having magnitude mx, hence a bounded input is giving me a bounded output, the system becomes stable. Is it clear, everyone? Homogeneity and superposition, it gives me linearity. Shift in time at the complete equation yt xt cos omega ct, and shift in time with just the input will give me time variance and invariance. If there is no future value, it will give me causal. If there is no future, no past value, it will give me static and memory rest. And if my input is bounded and output is bounded, it is going to give me stable and unstable. Let's take another system. So in this system, again, I have to check everything. This is a discrete system where xn is the input and output is nothing but it is shifting my xn by 1 unit. So it is a unit delay system. So let's check with the input. So I have given an input x1t, or rather it's x1, n, put it a x1, n. I'm getting an output that is y is equals to a times x1 n minus 1. Now I've given an input b times x2n. So my output y1, y2n will be b times x2 n minus 1. Now I'm giving a third input x3n, which is nothing but a times x1n plus b times x2n. So what I'm getting? I'm getting an output y3n, which is nothing but x3 of n minus 1. So whatever the n is there in x3, replace it by x of n minus 1. So I get a x1 n minus 1 plus b x2 n minus 1. So this is my y3. Now my y3n is nothing but it is equal to y1n plus y2n. So my y3n is nothing but it is equal to y1n plus y2n. Hence, my system is linear, not time variant and invariant. Let us say y of n is nothing but x of n minus 1. Replace n by n minus n naught. So what do I get? Y of n minus n naught will give me x of n minus n naught minus 1. Now, in the input side, feed x of n minus n naught to the system. So if I feed n minus n naught to the system, what I'll get? Y of n is nothing but x of n minus n naught, and it will be delayed by 1. So if you see yn is equal to y of n minus n naught, my yn is equal to y of n minus n naught. Hence, my system is time invariant. So my system is linear. My system is time invariant. And this will bring me to another system which is known as LTI system, which we'll be discussing in the next topic. So a system is linear and a system is time invariant. Now let us see causal and non-causal. Okay. So let's see. So my y of n is nothing but x of n minus 1. Substitute n is equals to 0. So my y of 0 is nothing but x of minus 1. So when my present output is at 0th point, my past output was, which has gone one delay back, one moment back. So it is x of minus 1. Let's put y of 1 will be dependent on x of 0. See, my present input output is dependent on my past input as well. So this system, there is no future concern. A system becomes causal. But if you see over here, my y0 is dependent on the past value of x. When we are going for static and dynamic, my y0 is dependent on the past value of x. So there has to be some storage of this. So for this storage, because of this, the system becomes dynamic system. That is memory system. There is a memory in this system. The last set, stable, unstable. See, magnitude of xn is, let us say, mx, some value mx, which is a finite number. Even if I shift a signal, even if I shift the signal left or right, my magnitude will remain finite. So magnitude of yn will also be less than equal to some finite number ny, and the system is stable. Is it clear, everyone? Since the magnitude of xn is you can say is less than equal to some finite number, similarly the magnitude of yn will also be less than some finite number. Let's try another question. So in this question, yn is equals to, it's equal to, it's not minus, yn is equals to n times x of n. So prove this as linearity. Okay. So linear system, it would be linear. It would be, I'm just writing, you have to prove it. Time varying system. Okay. It is going to be causal and it is going to be static. I've written the 4 characteristics of this system. You have to just try and prove it. Okay. Linearity, it is time varying, it is causal, it is static. Now what about stability and instability? Now here there is a catch. Let us say x of n has a bounded output mx for all n. If y of n will have a bounded output ny, then the system is stable. But my y of n will have a factor of n over here, factor of n times mx. Now this n, let us take x as un. So my y0 will be 0. My y1 will have a factor of 1. this n will keep on increasing with time, and there is no bound on this same. There is no bound. As soon as the time will go, this n will start increasing. So because of this n, this relation will not stand because there is no bound on this. We cannot bound the time. So n times if this magnitude is increasing and it is not going to get bounded, that's why the system become unstable. So in stability, you just need to check whether there is some variable which is having no bound, then my system becomes unstable. For example, we'll just go back a bit. See, in this system also we had a multiplication factor cos omega ct, but the output, the magnitude of this is going to vary between 0 to 1 for any value of t. The magnitude of course will vary from 0 to 1. So it will still have a finite number. Magnitude of x multiplied by 0 or magnitude of x multiplied by maximum by 1 will have a bounded number. But in this case, when there is a multiplication factor of n, this n is not bounded. This n can be 0 to infinity, whatever you can take a value of n on a time scale. Now, the last discussion, my LTI system. Now, at times they ask you, write down the properties of LTI system. So remember one thing, the first property of an LTI system is it is linear. Hence, it will satisfy superposition plus homogeneity. Time invariance, just write down this y of n will be equal to y of n minus n naught. So what is my y of n minus n naught? Y of n minus n naught is nothing but x of n minus n naught. And what is yn? Yn is output when input is shifted. So just write two lines. My y of n, which is an output, which I've got when I've just shifted the input. What is y of n minus n naught? When I've shifted the complete equation. Causal, past, input, past, output, present, input will give me present output. But remember, LTI system can be causal and can be non-causal. If it is a causal system, then it is definitely realizable. If it is non-causal, it is not realizable. So all these comes to the property of my LTI system. Can be dynamic, can be static. So these are the properties which we generally refer when we are asked what are LTI systems and write down its properties. So LTI stands for, remember this, linear time invariant. So this thing has to be true, linear and time invariant. All right, class. So this is all about classification of the signal. Just remember one thing, little by little, a little becomes a lot. Little topics, small kind of effort will together give you a big result. And one more thing, a little did of liking, sharing, and subscribing will help this universe expand. Thank you all. So please